So, ladies and gentlemen, welcome in today's webinar. In today's session, we will discover BricsCAD Civil Survey and the features that this particular license level has to offer. My name is Dimitris Sapios. I'm the Technical Pre-Sales Manager of the EMEA region, and in today's session, we will find out what BricsCAD can do in the civil surveying realm. So let's take a look at today's agenda. We have 5 points of discussion today. We will begin today's session by importing surveying data and surveying points and GIS information in the format of shape files. After the importing, we'll go ahead and create a thin surface out of the surveying points in order to create a digital twin of the terrain. Afterwards, we will start building on top of the thin surface by creating gradings and corridors. A volume extraction is also part of the process. And number 4, BricsCAD Civil Survey supports the importing of point clouds and the workflow of scan to tin. We use the Leica drones in order to capture a construction site, and with this process, we'll create a digital twin of the actual construction site. And by finishing off today's webinar, we will compare the construction site with our actual design in order to find out what the differences are and do quantity and volume takeoff. Let's begin by importing civil surveying data and GIS information. With this, I will go straight into BricsCAD and open up our software. In this particular example, I've already activated the civil survey workspace, which is nothing more than a different user interface, giving us the thin surface options, the point features, and on the bottom right side, as you can already see, we can quickly change the workspaces between civil survey and drafting. So that means BricsCAD as a native DWG software supports multiple workspaces that allows us to create 2D simple entities and also in the same software installation, importing thin surfaces and points. So if you're new to BricsCAD, I highly recommend you opening the tips side panel from the left side. This panel gives us a quick overview of the newest version, what is new in V25, and a quick rundown of the essential features of the civil surveying functionalities. So if you want to learn more about gradings, you click under Learn More, and you can find some animated GIFs, step-by-step instructions, and links to the help center that will help you creating gradings. With that being said, the civil surveying workspace offers a civil explorer on the left side. This is going to be the control panel for every civil and GIS entity we have in the drawing. And first things first, we need to import surveying data. The way we do that is by clicking on civil points, and I will import a file in this case. For our example, I will select a specific CSV file that includes a list of surveying points. It looks like this. We have 5 different columns. We have the number of the points. We have the northing, easting, the elevation, and a raw description of the boreholes. With that being said, we select the CSV files, the CSV file, and we select a specific format that can be applicable. In this case, I will find a name, easting, northing, elevation, and D for description. So after changing that, we can see a preview on this window, and the raw description is there. After clicking import, we will see the points being generated. From the status icons on the bottom side, we can switch the scaling at any point of the process, 100 to 10 to make it more visible. And after going into the Civil Explorer, we can find an overview of the points under the grouped points. So this enables the point editor. We can get an overview of the points and the raw description. And we can, of course, change the visualization of those points by visiting the settings on the right side. Over here, we'll find some general settings, civil point settings, and options that govern the thin surfaces. So in the case of the symbols, we can go ahead and enable that and change the visualization of the symbols and change the visualization in order to achieve this particular example. We can change the colors, we can make the description visually better, and create 2D deliverables for your surveying data. On the next file, we will see the result. We can create 2D plans of your traverses. In this particular example, we captured a particular road, and this is the final result of the 2D plan. Let's move forward and talk about GIS data. I'm going to open a separate file, and I'm going to visit the Civil Explorer once again. In this case, I will enable the GIS tab and import GIS layers. So here are the file formats we currently support: Esri shapefiles, KML, and Esri geodatabase. So in this example, I will select my files. I will find the shapefiles. We can select multiple at a time. And after opening and importing the files, we will see the GIS layers. They get identified, and the GIS data that come along with the importing. Let's click on import, and we'll see the results. In the modeling space, these are 2D polylines that represent the railways and the road crossings. So important thing in the GIS workflow are the data and the attributes. So by clicking on an object, we can enable the properties side panel on the right side. And by scrolling all the way down, we find a section called GIS, and all the attributes are visible and ready to be furtherly edited. On top of that, we can, of course, double click on the GIS data on the left side and access the attributes, enable some different categories, and even edit them on the spot. These are the functionalities of the GIS data in the 2D civil surveying functionalities. So let's go back to the agenda. We finished the first point, and let's now go ahead and create thin surfaces and create an anaglyph of the terrain. So there are a couple of ways of creating thin surfaces. Let's go back to the initial drawing. We can create thin surfaces out of civil points, or we can use topography contour lines in order to create that. So with a couple of simple steps, we enable the thin surface, and in this case, I will just select the civil surveying points and just hit spacebar. Just a couple of clicks away from creating a thin surface. We can do the exact same thing by using topography lines, and by hovering over the entity, the quad menu of BricsCAD, which is a context-sensitive toolbar, identifies the object, this is a thin surface, and gives us a list of commands that can only be applied to thin surfaces. We will discover them in a little bit. So let's see a more complex example of a thin surface creation. For that, I will open up in a different file. In this particular example, I've already inserted a georeferenced image. By going under the Insert tab, hitting Attach Image, I will find the image, the TIFF file, and the georeferenced object, the georeferenced file, and import it in our drawing. So after doing that, I will need to create a thin surface out of a list of text files that describe the points of the geometry. So in this case, I will select Import from File. I will visit the same dialog window as before, but in this case, I will not select a CSV file. I will find a list of points that include X, Y, and Z coordinates. I will open it up. The format is already predefined, and we have easting, northing, and elevation in this case, just those three columns. By hitting on import, we have the option of simplification, of simplifying the tin surface, but in this case, I will hit on no. And I will, by clicking on no, this will use every single point available in the text file in order to create the tin surface. As we zoom right in, we can see the anaglyph of the terrain. And in order to make the drawing a bit lighter, I want to isolate and focus on a more specific region of the map. And for this example, I've already created a blue polyline that represents the boundary I want to use. This is a 2D polyline. So in this case, I want to add the boundary, but I'm not entirely sure what the command is. So in this case, the quad menu will help me by visiting the civil tab. And these are all the commands that can be applied to tin surfaces. There you go. First option, add boundaries. I will select the object that represents the boundary, and I will just accept the standard options. There you go. This command trims the tin surface according to the boundary. And remember, this polyline can act in a dynamic way, meaning that I can change the grips, and this automatically changes the trimming of the geometry in a dynamic fashion. So the link stays there in the background. Okay, what else do we want to do? I can assign the georeferenced image to my tin surface. By hitting on this option, I paint the tin surface according to the georeferenced image. Okay, so now we have the resulting tin surface in our drawing. Let's select all the entities that are not relevant anymore, and I will click on Hide All Entities again in order to work in a cleaner manner. So what can we do now with a tin surface? This is a nice visual representation of the terrain, and by enabling the Civil Explorer, we can find some more visualization options. I will select the tin surface, and on the bottom side we have some settings that gives us some information about the tin surface, the definitions and the steps we took in order to create that. And statistics gives us an overview of the number of triangles, minimum and maximum elevation in meters, and there you go. Final tab, the visual styles of the tin surface. Let's make this a little bit bigger. So triangles are on at this point, meaning the finite elements that represent the tin surface. I can enable the contour lines, the topography lines. We have a major every 10 meters and a minor every 1 meter that get represented with a green and red color. So this is the visualization. And on top of that, we can deactivate the triangle, so we can only get a visualization of the contour lines themselves. So as we zoom right in, we might notice something. We have some jagged lines that are a direct result of the triangulation that followed. In BricsCAD, we introduced earlier in the earlier version a simplification or a smoothing tool. By making a right click on the tin surface under Edit, we can smoothen the tin surface and get rid of the jagged lines and make it appear a bit smoother. On the bottom right side of the software, you can see now there is a small loading screen. There you go. So we will let the calculation finish, and afterwards we will see a more smoothened surface. There you go. In this case, I will just accept the standard settings. And I will let it for a couple of seconds to finish the calculation. Okay, we're almost there. Take a note in this case that this is a particularly big thin surface capturing multiple kilometers of terrain, and the calculation just finished. This is an excellent example of how quick BricsCAD is because it utilizes multi-threading technology that uses multiple CPU cores of the system. So there you go. Now the jagged lines have been significantly improved, giving us some nice smoothened lines along the terrain. So let's see what else we can do with this particular example. If we go under the surfaces functionality, there you go. Under this particular register panel, we have a water drop simulation. We click on the thin surface, and by moving the mouse, we can dynamically see the direction that a water drop takes once we leave it, once we place it in a particular area of the thin surface. This is an interesting functionality. And what else can we do in terms of labels? There you go. Once we visit the register, the panel labels, we can add surface labels on the thin surface. We have three options. We can add contour lines. We can actually name the contour lines. We can add spot elevations and slopes. So let's see how that looks like. I will enable the contour lines, and I will use the default label style name. This, of course, can be edited in the Civil Explorer settings. And now I will select the thin surface, and I will start from here to there, and it will create a labeling across the contour lines. Okay, it will take a couple of seconds for it to load. There you go. And after zooming in this particular region, we can see the surface contour labels being created for every contour line in the drawing. You can, of course, change the annotation scale and make it smaller, make it bigger, and more, and it being more visible. And in this way, we can create the descriptions for every contour line. What else can we do? We can add the slopes by using single points. And in the exact same way, I just click on a point, and it will give us the slope in percentages. And on a final note, we can quickly add spot elevations in our thin surface. Selecting the thin surface again and just clicking gives us the elevations by using a specific block within the drawing. So all those options and labeling styles can be changed. Okay, so these are some functionalities of the thin surfaces, thin surface creation, and thin surface description in terms of labeling. Let's see now what we can do on top of this thin surface in order to create gradings and corridors. I will use the same data set, and I will go back into the Civil Explorer and change the visualization, bring back the triangles in order to make the geometry more visible. Okay, I will disable the contour lines, and I will go ahead with the gradings. So, okay. Take a couple of seconds for the thin surface to refresh. There you go. And let's zoom in a specific region right here. So the way that BricsCAD works with gradings is this. With this functionality, we use a 2D or a 3D polyline in order to create an input entity for the grading. Let's give you an example. I will use a rectangle with the command rec, and I will create just an input entity, 100 units and 100 units in this area. Oh, where was it? Landed all the way down because I didn't enable my snaps. No, everything is active. Okay, let's do it again. A rectangle. Is it because it's movement? Okay, let's go into another area right here. And I will do a rectangle in this particular area. And I will use now this polyline as an input entity for my grading. I will enable the option, select the polyline, and now I will select the target surface, which is going to be my tin surface. And I want the grading to run for the entire length of my input entity. And now with the movement of my mouse, I can decide the angle of attack of this particular grading, say 45 degrees, and press enter. Now this is a grading inside my drawing, which clearly cuts the tin surface. I don't see the final result yet because we need to activate a couple of settings for this grading. Let's go into the properties and see what we can do. First of all, this is a grading, and just as a tin surface, we can change its visibility. We can enable the contour lines, and because this grading was created by a polyline, the initial polyline acts as a dynamic link between the tin surface and the grading, meaning that I can click on the green grips and change its geometry as we like. Let's click on the grading once again and scroll a little bit downwards. Under grading settings, I need to enable the boundary in order to see the end result. There you go. Now we can clearly see the cutting area of the grading. We can we can change the corner type, make it sharp. There you go. And by scrolling all the way down, the final part of the settings are the grading statistics. Over here, we will find the fill volume, how much soil we need to fill in this particular area. And cut means how much soil we need to excavate from this particular region. Net volume means the difference, what's the difference between the cut and the fill. And in BricsCAD, in order for you to save construction costs, we can find the grading and enable the option of balancing the grading volumes. This feature finds out what the elevation of the grading should be in order for the net volumes to be 0, so you don't have to bring in or excavate extra soil. So this is an interesting functionality right there. And we can, of course, create interesting gradings with other entities, like a simple line in this case. Let's create a nice little dam along this canyon, shall we? So let's go ahead and create a 3D polyline from this edge to the other, connecting those two hills. So by using the same command, grading, we will use this polyline as an input entity for the dam. I will select it. I will do an offset in this case because I want to create a road on top of that. And I will use the entire length, and I want it to be 2 meters wide in the right direction, and I want a 0 angle of attack. Okay, I will accept it. I will repeat the same process. Do another grading by using the initial polyline, do an offset for the entire length for 2 meters and 0 degrees. And now we'll do the same thing. I will just connect those gradings with the tin surface. one step and two steps for the target surface creation. There you go, selecting the angle of attack, 45 degrees. And I will do the exact same thing for the other side. Select the target surface, and now the slope can, of course, be different. Let's do 30 and create the geometry. The interesting fact about this grading, same as the grading we saw before, its geometry is governed by the input entity. The polyline I just created controls the geometry. Here you go. Now we just found a new solution for the system. I will bring it here, and he will automatically connect the gradings with my thin surface. There you go. So I can connect it over here with this road and make something like this. Okay, what happens now with the volume calculation? How much soil do we need in this case? There are two simple steps. First of all, we have 4 different gradings, right? 2, 3, and 4. And I will remove the merged thin surfaces, resulting in a single thin surface. Now this, if I isolate the entity, this is just a thin surface. It doesn't have any thickness. It's just a surface. So how do we create a volume out of it? Same way, I just go into the Civil tab of the quad menu and try to find extraction options. Extract from thin surface is the command that I need. And we have multiple options. We can extract contour lines, but over here, what we need is the final option, extracting solids and meshes between the surfaces, right? So I will need to select the thin surface that I need to compare it with and extract it. So in a couple of seconds, the software will build 3D solid between my thin surface and my grading. There you go. That's the end result. A 3D solid was just created, and let's go ahead and isolate the entities and see how it looks like. Okay, this is a 3D solid of the volume we need to fill in, and data extraction actually happens in the properties panel. There you go. It's trying to compute, and this is the volume of the soil we need to fill in. So this is how quick we can find out how much soil we need to bring in this particular project. Okay, let's go back to the agenda. We just created gradings in 2 different manners. And what else is remaining? Corridors. In BricsCAD, we can create some simple representations of the corridors and the roads of the project. So let's get rid of the grading and zoom out. In this particular example, in order to create a road or a corridor, as we call it, we need, first of all, to create a 2D representation of the section. By using simple lines and polylines, we can create corridor templates. Once we create them, we basically define an axis that is used for the extraction/sweeping functionalities. And for those profiles, we can go in and define materials, just like we see here in this case, the asphalt layer can be defined. And also we can define the angle of attack, what's the angle of the grading that connects our thin surface with the corridor. So now with after creating the corridor templates, with just a couple of simple steps, we can create 3D alignments that define the direction that the road takes. Clicking on the alignment, I will select the thin surface that I want, and I need to decide where the road begins and which direction it takes. Now this is a 3D alignment. On the X and Y plane, on the bottom, we see a horizontal alignment. that can be changed. And on the properties panel, we can find its elements and some information about its length. So after having this, we just click the corridor option. I will select my 3D alignment, and now I need to choose a template. I go here and I select this template, and I will need then to define a starting station. Now I need to decide from where until where does my corridor run. I will select the start and I will choose the end, and this creates the corridor. Of course, we have some irregularities over here. There is some soil we need to cut and trim. And in this case, I will show you the final result. This is the corridor we can create in BricsCAD. We can define the angle of attack not only for the filling gradings, but also of the cutting gradings. There you go. And another interesting feature about the corridors is the fact that we can change and we can easily edit the vertical alignment in order to control the height of each individual point. Let's see how we do that. In this case, I will enable a secondary viewport to split my screen into two segments because I need to focus on two different areas at the same time. So let's see the corridor from this angle, and on the other angle, I have created a vertical alignment. This window, this is the command, vertical alignment. This window basically gives us a representation of the actual thin surface. This pale blue line gives us the anaglyph of the terrain itself. And this right here is our vertical alignment. This is how the corridor currently runs. I can go into the properties panel and select each PVI point. You see the white cross on the left side, and I can cycle through each individual PVI point and change its elevation, either by typing in a new elevation inside the properties panel, or by going in and just getting the grips and moving it up and down. And by doing it this way, I can see the change of geometry happening real time on the top side. Okay, so this is a quick overview of the alignments. And let's now go back to the agenda and talk a little bit about the point clouds part of the software. In BricsCAD Pro, in the Pro license level, that includes the civil surveying functionalities, we can import point clouds without any add-ons whatsoever. So let's go back in another example drawing that I have ready. And we are in the civil surveying workspace once again, but in this case, we will visit the point clouds tab. This is a part of BricsCAD, and this allows us to enable the point cloud reference manager, which is the control panel of the point clouds, and process a new scan. So whenever you receive an E57 file format or any of the supported files that you can see in this list, we can import them, pre-process them in a BricsCAD native format, and bring them in the modeling space. Let's see how that looks like. In this example, I will just select this point cloud of the construction site, and later in this stage, I will compare it with my actual design. So let's see how the process looks like. This is the point cloud of the construction site. I can zoom right in. You can see we have with the command distance, we have 1 point every half a meter, 52 centimeters, 71 centimeters. So the detail is quite medium, but it's quite sufficient in order to do the volume calculations. So what can we do now with the point cloud? The same way we created a thin surface out of the civil points and text files. With the same commands, we can create a thin surface out of a point cloud. I enable the same command, but in this case, I will create a thin surface from a point cloud. I will select it, and I will say yes to simplification. This will save some processing time, and it will simplify this thin surface. I also have the option to densify it, but I hit no in this case because I will do it in a later stage. Let's see how the simplification looks like. As I start zooming in, I notice that the detail of the thin surface is quite low. It ignored many points with each distance or elevation I defined earlier. So in order to fix that, let's first of all, let's make it a bit more visible by turning on and off the point clouds. We can already see the detail is quite low. So let's fix that, shall we? In order to do that, we need to go into the Civil Explorer and find the thin surfaces. So in this case, under the definitions, this is the step I took in order to create the point cloud. So I can go back again and find the settings that I used. The simplification is on. So what I need to do is just turn it off and enable update the surface once again. There you go. The loading happened in real time, and as soon as I close it and start zooming in on the thin surface, we can clearly see that this time it used every single point available to connect the triangles and make the thin surface. We can change the visibility of the point cloud by visiting the point cloud manager on the top right side. And under the rendering settings, we can change the point size, make it smaller or bigger. And let's go ahead and see what else we can do with a thin surface. In this particular example, we have many construction site vehicles on the site. We have a couple of cars, we have some heavy machinery that deform the geometry and create unnecessary noise. So in this case, we can use the quad menu again to get rid of the unnecessary points by removing the points manually. Of course, if we have many grouped unwanted points, this is not the way to go. It takes a couple of, it will take some time in order to remove everything, but we have a more specialized tool in order to get rid of this car. And to make it visually better, let me disable the point clouds and change the layer of the thin surface in order for the contrast to make it more visually appealing. Okay, so this is the thin surface, right? By visiting the quad menu once again, we have a tool that smoothens the thin surface under a specific radius, 10 meters. I like to call this a makeup tool. This tool basically finds an average elevation at which he flattens the thin surface. So if I completely include this deformation inside the circle and just click on it, it will smoothen it and it will get rid all of the unwanted points at once. So we can of course play around with the radius to make it as good as we want. And there you go. We just fixed the irregularity. So this is a point cloud of the construction site. And the reason we capture that is to compare it with our actual design and find out what the differences are in terms of volumes. So let's see how we do that. For this example, I will open up the actual design of the construction site. I have the 2D plans and an anaglyph of the surface. We have 3D polyline, 3D topography lines in a specific elevation. And by using those 2D entities, I created a thin surface of the project I want to achieve. Just a couple of seconds, the software is loading. There you go. Okay, So by using those 2D plans, I have already created a thin surface of my actual design. This is the target, right? So let's enable the construction site on top of that. So we can clearly see once we enable two of them at the same time, we can see the differences in a visual manner. We clearly need to excavate a lot of soil in this region. We need to cut a lot of soil in specific areas. So I want to compare those two thin surfaces. And in order to do that, thin volume surface is the answer. So this command actually requires some interest areas in the form of polylines. So in this case, I've created two polylines, just 2D polylines, in order to define my interest areas and compare those two thin surfaces together. So by clicking on thin volume surface, he asks us about the base thin surface, the comparison thin surface, and the bounding area as an interest area, so to say. And after enabling the commands, on the X and Y plane, a thin volume surface will appear, and it will paint the cutting areas with the color red, and the green signifies the fill, right? This information can be found under the Properties panel. Same as the gradings we saw before, the same thing applies to the volume surfaces. I will scroll all the way down and I will find the cut volumes and the fill volumes. So this is my deliverable. You can of course use those values as I see them and copy them. But in BricsCAD we can use a data extraction tool to create a nice little table on top of my grading and my volume surface. So by using the command data extraction, I enable this little wizard. We'll hit on next, and I will select the entity I need to extract data from. In this case, I want this volume surface. I will go on next. There you go. Thin volume surface is identified. And now I get to select the properties that I need. I need a name. I also need the number of triangles on the thin surface. And I need my fill and my cut volumes. So by hitting on next, we can output this file as a CSV file and create a table with or without data link in the modeling space. So let's click on finish and hit on an insertion point. And there you go. This is the table that I need that describes this particular thin volume surface. We have its name, the number of triangles, and the cut and fill volumes in cubic meters. And to wrap up today's session, I will use this exact same data set in order to demonstrate to you the final results of the actual project. Let's close down the thin surfaces and the construction site. We can activate the 2D plans on top of the thin surface. We can enable the representation of the buildings that will come afterwards and get built on those particular spaces. Now take a note, we can use those 3D solids and visit the BIM workspace in order to create an actual building and raise the BIM detail level, but we will not do it in this webinar. And what else can we do? We created corridors the same way as I demonstrated before. We defined a template with a series of layers and materials, and we applied it on a 3D alignment. You can see the materials right here. If we want to extract information out of this corridor, we can go ahead and visit the Civil tab once again and extract something from this corridor. In this case, I want to extract a solid in order to find out the volume of the asphalt. And I had given it a code earlier on. So by hitting codes and typing in asphalt, it will extract a solid out of this particular layer. So there you go. In this case, I've given a code only to the left side of the asphalt, but after clicking the 3D solid, I can go into the properties panel and find out how many cubic meters of asphalt I need in my project. And to wrap up today's session, we can also calculate the volume of water we need to fill in this particular lake. And ladies and gentlemen, this is an overview of BricsCAD civil surveying. After finishing point number 5, quantity and volume takeoff is a direct result of the corridors and the thin surfaces and gratings. So, yeah, thank you very much for your participation